Hey everyone, Techno here. In this video, I'm going to talk about why 3D printing is so awesome and what cool things you can do with 3D printing. There are many different types of filament uh, that ranging from your typical PLA and ABS, starting with your default white color or any other color, to nice little offshoot types of plastic like PET, PETG, uh, HIPS, and then there's this cool one called Amphora, which is specific. Even though it's just an offshoot type of plastic, this was specifically grown in a lab. It was made in a lab, and it was specifically made for 3D printing, unlike other thermoplastics, which had just been repurposed. And then there are cool ones like filament, wood filament, and metal filament, and flexible filament, light sensitive, temperature sensitive filaments, which are all very cool. They give you different types of things for different purposes. And here's a link over here, and also the links in the description if you want to go check out some more types of filament. And there are also many different filament colors, ranging from virtually every color in existence to also some weird types of filament like glow in the dark. And again, the temperature and light sensitive color changing filaments too, like I mentioned earlier. And I also like 3D printing because there are many different ways you can even if you don't have that much experience designing it, there's a huge library of 3D designs online, and you can literally find anything in places like MakerBot, Tinkercad, Thingiverse, and there's also this link in the description where there's sites where you can find 3D models online. And if you want to make something yourself, of course you can make it in places like Tinkercad, 3D Orchid, etc., etc., etc. And you can do stuff. And what I forgot to mention is that if you have a slicer software, you can also customize 3D prints further by changing the attributes. Like there's stuff like adhesion, which is basically how much it sticks to the build plate, um, so that it doesn't pop off the build plate when it's still printing. There's support, which is basically like scaffolding. It's just structures to support parts of the model which have overhangs, like it says over here. And this is the thick or the thickness of the extruded filament. The thicker you want it, the thicker the filament, like the better for structural prints. The thinner the filament is better for detailed work. Like yeah, average thickness is about 0.2. You'll be fine for just about anything. It's a reasonable amount of detailed work as well. And also there's this thing called infill, which is actually how much percentage of the 3D print is actually plastic and how much percent is air. This infill of 25% means that the model is 25% air, 25% plastic, 75% air. How is that gonna work? How is that gonna work, right? Isn't doesn't it seem a little weird? How is it 25% plastic gonna even hold itself up? Well, the answer lies in the way that it's been set up. It's like a beacomb structure. Beacomb structures are mostly filled with air, but they're very solid. They're made of wax, but still, if there's a steel version of that, that would be extremely powerful, even though it's mostly air. Same thing goes for plastic. Even though it's like mostly air, it's still rock solid, and you don't even need to put even like 50%, because that would be a huge waste of filament. You get this virtually the same amount of durability. So, and it also saves a large amount of filament and energy too, so that's really cool. So, and yeah, let's go back to this. And again, I went over this already. And last thing I'm gonna tell you about is there's basically I would basically say the sky's the limit when it comes to 3D printing, but it isn't. There's really no limit if you have either you'd have to have basic experience with 3D printing. You gotta know your way around the 3D printer, like what parts are, how it works, etc., etc. And you gotta have either knowledge about finding 3D models, or you have to design, you know how to design the 3D models yourself. And last thing I was gonna say, 3D printing is very good for fixing practical problems. Practical problems, like for example, I like to play this game called Carom, which is basically like similar to pool, but except it's not played with like a stick and like a like fun pool balls, but it's played with a disc and a big disc and the smaller discs. And the big disc, the striker, started getting all worn out, and it was starting to get more have more friction. So I decided to design my own disc, carom disc, by 3D designing it, printing it. I put a little hole in it so I could put a washer. The result was amazing. It was better than a normal. It was better than even a normal filament, normal carom disc, a striker, and it was almost frictionless, and it was very powerful too because of the washer inside. There are so many problems just like that you can solve. 3D printing is being applied into many fields, ranging from engineering structures to even medical field, where 3D some stitches are being 3D printed. There are biodegradable 3D printed materials, and they're looking into 3D printing organs as well too. So this is an amazing field, and it needs lots of innovation and talent. It's a great field, amazing to work with, and I hope you enjoy uh, looking into this, exploring 3D designing, and stay safe, enjoy your day, and